Hi, good morning. Today we are going to discuss about linear search technique using recursion. Linear search or sequential search. Linear search is a simple algorithm that searches for a target item in a list of items by checking each item one by one. The target element is compared with the elements of the array one by one from first element to last element till it matches. If the target item exists in the list, the function returns position of target item. Otherwise, the function returns -1 to indicate that the target is not found. We can perform linear search in two ways. One, iterative function, the other one, recursive function. In an iterative function, loops are used to execute statements repeatedly. Recursion is a special case of process where a function calls itself. A function is called recursive if a statement within the body of function calls the same function. We can implement a linear search function to find position of target element using recursive function also. First, let me explain about sequential search using iterative method. Let us consider the following array A consisting of 10 elements. Now, search the target element 89 in the array using iterative linear search function. The array contains 10 elements. The indices are from 0 to 9. The elements are given there and the target element is 89. We wanted to search for target 89. So target 89 is compared with every element from first element to last element of the array. Initially, the target 89 is compared with A0. It is not equal. 89 is not equal to 25. Now, target is compared with next element of the array, that is A1. 89 is compared with A1, which is 10, not equal. 89 is then compared with A2. A2 is 15. Again, it is also not equal. 89 is compared with A3. It is also not equal. 89 is compared with A4. It is equal. So, the target is equivalent to element of array at index 4. So, position of target element is 4 in the array. So, 4 will be returned. So, here we write a function, iterative function, linear search, int linear search a n x. A is array, A is array, n is number of elements in the array, x is the target element. Then initially position is considered as -1. -1 means the target is not found. Before comparing target with any of the elements in the array, we assume that the target is not found. Then we start comparing from 0th element, first element, second element, third element, etc. up to last element till there exists a match. So for I assigned to 0, for this we use a loop statement. Here I have used for statement for I assigned to 0, I less than and I plus plus. So 0 to n minus 1, all the elements will be compared. Whenever ai is equal to x, that I is assigned to position and break is executed, loop is terminated. Once it is identified, no need to compare with next item. So a break will be executed so that for will be terminated, then position will be returned. Position value will be returned here. This is the way where an element is identified in the array. Position is 4, 4 will be returned. Now, let me explain about sequential search using recursive function. Let us consider an example, array A consisting of 4 elements. The indices are 0 to 4. Here we write a function, a recursive function, linear search. Linear search is a recursive function. The formal parameters are a, n, target. A is array, n is number of elements in the array, target is the target element we are going to search for. Here, see the statements. If n is 0, n is 0 means number of elements. number of elements in the 0. If number of elements in the number of elements in the array are 0, then we can't find target element. So return -1. If number of elements are 0, there is no question of finding our target element. So return -1, not found. Otherwise, else target is compared with a n minus 1. N minus 1 is the index of last element. So we are comparing target element with last element of the array. If the target is equivalent to last element, return n minus 1 index of last element. Otherwise, linear search, we are calling again linear search function a n minus 1 target, means we are calling the same function again. We are calling the linear search function again. In the linear search function, we are calling linear search function by reducing number of elements by 1. See the series of function calls. Initially there are 5 elements in the array. Here first call linear search a 5 15, where 15 is our target element, a is array, 5 is number of elements in the array. A is array, 5 number of elements in the array, 15 the target element. Now I am going to compare 15 with the last element in 5 elements. So there are 5 elements. Last element is last element equal to 15? No. So last element is not equal to 15. So excluding that last element, we are going to compare the target element in the remaining elements. Now it calls linear search function a415. Initially there are 5 elements. Now by reducing one element, I am calling again linear search function. Linear search a415 means in the array A, assume that there are 4 elements. Compare 15 with last element. Last element you can get in 4 elements. Last element of array where there are 4 elements, the index of last element is 3. Third element is compared. Is third element equivalent to 15? No, it is also not equal. So as it is not equal, then now search target element in the remaining 3 elements. Linear search a 3 15. So 15 is compared with third element. Third element you will get at position 2. So yes, it is equal. So position is 2. It returns 2. See, every time it checks is n 0. N 0 means if number of elements are 0. If number of elements in an array is 0, there is no question of getting our target element. Otherwise, is the target element equivalent to last element of the array? If it is equal, last element position will be returned. Otherwise, reduce number of elements by 1 and repeat the same procedure again and again. So in this way, the linear search function is called in the same function. It is said to be recursive function. Let me explain sequential search using recursion with another example. We take the same array, but the target is different. Now I'm going to search for 55 using recursive function. So is 55 equivalent to 89? No. Is 55 equivalent to 75? No. Is 55 equivalent to 15? No. Is 55 equivalent to 10? No. Is 55 equivalent to 25? No. So none of the elements are equivalent to our target element. Even after 5 comparisons and 5 function calls, we didn't find our target element. Means it is the worst case condition where we didn't find our target element in the array. The sequence of function calls are like this. Linear search A555 means A is array, 5 is total number of elements in the array, and 55 is the target element. See next linear search function call A455 means A is array, 4 is number of elements. So initially we compare in 5 elements, last element. We compare in 4 elements, last element of 4 elements. We compare in last element of third element, 3 elements. We compare with last element in 2 elements. We compare with last element of 1 element. We compare with no elements, 0. Means n is 0. N is 0 means if n is 0, there is no question of finding our target element. So it returns -1. So if n is 0, it returns minus 1. Otherwise, it compares with last element of that particular array. If it is equal, n minus 1 will be returned. Otherwise, it calls a function call by reducing number of elements by 1. Efficiency of algorithm is calculated through time complexity. The time complexity of linear search may be calculated as three cases: best case, average case, and worst case. Best case means identifying target element with just one function call or one comparison. Average case means identifying target element with the help of n by 2 number of function calls or n by 2 number of comparisons. Worst case time complexity means identifying target element with maximum number of function calls or maximum number of uh, comparisons. Maximum number means if there are n number of elements, n number of function calls or n number of comparisons. For example, the best case, you wanted to identify 89 in the array given there, where the array contains 25, 10, 15, 75, 89. In recursive function, to identify any target element, the target element is compared with last element first. So 89 is the last element and 89 is our target element. So the position is 4. With just one comparison or one function call, we got our target element. So order of 1 is the time complexity using recursive function. Next one is average case time complexity. Identifying position of target element in n by 2 function calls, which is said to be average case. The position of target 15 can be identified in 3 function calls. See here in recursive function, where initially we call linear search function, recursive linear search function A5 15. 15 is the target element. We are going to compare 15 with 5 elements of the array. So fifth element is 89, which is not equal to 15. Then we call next linear search function. Linear search a comma 4 comma 15 means in 4 elements we are going to compare 15 in 4 element in first 4 elements. So last element is 3, which is not equivalent to 15. So again we call linear search function with 3 elements. So last element in 3 elements. So it is second element. Second element is 15. It is equal. So in just 3 comparisons, we got our target element. So here it is considered as n by 2 number of function calls. So n by 2 number of function calls means it is considered as order of n. Order of n, see here. Order of n. So average case comparisons or average case function calls. Let me explain about worst case time complexity. Worst case time complexity means identifying target element in using maximum number of function calls. For example, let us take the same array 25, 10, 15, 75 and 89. Target element is 25. Target element is considered as 25. We are going to search for 25 using recursive function. In a recursive function, the target element is compared with last element first. 25 is target element. Is it equivalent to last element? No. Is it equivalent to previous 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 element? Yes. Yes. So see here, after 5 comparisons or after 5 function calls, every time you compare using a function call. See, linear search A525 means A is array, there are 5 elements and 25 is your target element. So it is comparing with fifth element. Fifth element is not 25. So it calls next function call. Linear search A425 is 25, the fourth element Fourth element is also not 25. Is 25 equivalent to third element? No. Is 25 equivalent to second element? No. Is 25 equivalent to first element? Yes. So first element's index is 0, which is position. It is returned. So after 5 comparisons, we got our target element. So 5 means 5 function calls. So 5 function calls means n function calls in here, as there are 5 elements in the array. So it is order of n. Order of n is said to be the worst case comparison, worst case time complexity. Even if the element is not found, it is not present in the array, still we get worst case only.